Hi, I'm Randall Heyman, a university academic. Welcome to my Corona Help playlists where I make quick turnaround videos to help educators and students. If you'd like me to make a video for you, then just comment below any of my videos or you can send me an email. Okay, so someone's asked me, this is not basic primary school multiplication and adding tables. You probably worked out, seeing this will be in the abstract algebra playlist. But someone's asked me about determining whether something's is a field, and they have to look at the multiplication and addition tables, and I think they're interpreting that incorrectly. I think that's the guts of the problem for that they're having here. So I thought what we'd do is draw up some multiplication tables, and we'll go from there. So I'll just draw this one here, and this one can go there. They're actually pretty simple tables, but I'm just trying to make it look a little bit neat. And let's go from there. Okay, so let's call this one addition, this one multiplication. Now in our case, this is actually addition and multiplication are modulo. So let's have a think of how we're going to express this. This is 0 plus 10z. So this actually comes about from 5z quotiented out by 10z. But you don't need to worry about that if you're not familiar with that. So let me just write some of this and then I'll explain what I'm doing here. So what do I mean by 5 plus 10z? I mean the set ... negative 15, 5, negative 5, 5, 15, etc. So this just means, take the z just means an integer. Take any integer, multiply it by 10, or take all the integers, multiply by 10 and add 5. Okay, and we can do the same for multiplication. So I'll just write these in. Five plus 10z. Let's write that in nice and neat. Wow, this is looking neater than I am normally. Okay. Okay, so just focusing here. If we add, so just here, yeah. So if we add a multiple of 10, which is this, to a multiple of 10, then we get a multiple of 10. If we add a multiple of 10 here to 5 plus a multiple of 10, well then we'll get 5 plus a multiple of 10. And here we'll get 5. And of course here we're thinking 5, this might be 25 plus 45 is 70, and 70 is divisible by 10. So here we're getting 0 plus 10z. Now when we go over here, now we're multiplying, this will be 0. Now this one here, this is a multiple of 10 by 5 plus a multiple of 10. So this, you might think here 20 times 15 is 30, it's a multiple of 10. And here 5 times, this one here is like 25 times 30, So that's going to be 0. And this one here, 25, you think 25 by 50, 25 by 25 is 625. That's 5 plus 10, 7. Okay, so now we need to interpret it, and this is where the problem's coming. Let's just rub out a few of my marks. So the first thing we need to do, if we're concerned here about whether something's a field, and in particular, we need to look at multiplicative inverse. But the first thing to observe here is this one here. This is you can see here when we add this on to anything, it doesn't change it. So this is 0 plus 10z is the additive identity. I think that's the term. It's a thing when we add it on to anything, it doesn't change it. And this one here, now let's go to multiplicative over to this side here. So this one here, this makes sense now because this is that we were saying this is this 0, what we would normally call the 0 element, and you can see when we multiply it here and here, we get we always get 0, so that's behaving as we would expect. Now this one here is essentially this is like the 1. It's the multiplicative, multiplicative identity. Why is that? Well, you can see that when we multiply this by this, we get that, which is the same as that. And when we multiply this by this, the answer down here is the same as this one up here. So this is acting like the 1 in the integers. When we multiply it by anything, well, we get the same thing. It's any multiplication is unchanged by multiplying by that special multiplicative identity. Okay, now what about inverse? Well, fields require an inverse. Fields require they require quite a few things, but one thing they require, and what's relevant here, is they require a multiplicative identity. They require an inverse. An inverse for each, actually I should say a multiplicative inverse. That's better. A multiplicative inverse for each term except the 0 term, I'll call it, which here is, in this case, the 0 term. The 0 term is 0 plus 10z. Okay, so what does that mean? So therefore, the field in this case, well, so let's say this field, or this potential field, requires a multiplicative inverse for inverse for, well, let's just go back here. We said fields require multiplicative inverse for each term except the 0 term. So that means this potential field requires a multiplicative inverse for 5, plus 10z. That's the only element other than the 0 element. Now, in fact, if you look at the table, let's go back to the table, you can see here that this does have an inverse. It has its inverse. It's itself an inverse. It is a self-inverse, if you like. I'm not sure what the proper term there is. In fact, 5 plus 10z times 5 plus 10z equals 5 plus. So the way to think about it is that this here is like the 1, or sort of like 1 in the, this is the what I've referred to up here. It's the multiplicative identity, and here is, this is, you know, every element apart from every element except 0 plus 10z. So here we've got the 1, or the multiplicative identity. We say, let's take an element, let's take every element in fact, and the only one is this one here. And in fact, when you there has to be an element that you can multiply to get this. And in fact, it's the same one. So the confusion here is because this 5 plus 10 z or z, depending where you're from, it's fulfilling 3 functions here. It is the multiplicative identity, which is here. It is the every element except 0 plus 10z here, and it is also happens to be the number that you multiply. In fact, this is the inverse. So this is the identity, multiplicative identity. This is every element except 10z, and this is the inverse for that element. So in terms of what I've shown you here, this satisfies everything for a field in terms of this specific thing about having an inverse. So I hope that's helped the person who asked me for help with that one. They were getting a bit confused with all these, with how the 5 plus 10z can fulfill more than one function, I think. So hopefully that's helped. If you've got any more questions, just comment below any of my videos or drop me an email.